Completing the square, Algebra 2 trigonometry regions. Solve for x by completing the square. So completing the square is a method which we are really only going to spend about a day on in this course. It helps us solve quadratic equations such as this. Now this particular equation, I purposely am doing one that this is a factorable equation and we'll solve it, and so I'm going to show you a couple of ways to solve this. But a lot of quadratic equations are not factorable. Their roots or their solutions are radicals or irrational. They may be imaginary numbers or complex numbers with I. And so they're not factorable terms. And so you have to use really one of two procedures to solve for roots that are irrational or imaginary, and that is either by using this completing the square method, which I'm about to show you, or by the quadratic formula, which is what our next video is going to be on. And the quadratic formula on the next video, that's really a bigger piece of this course this year. But if you're planning on taking pre-calculus or calculus in the near future, then this completing the square skill is used very heavily in those courses. So the first thing about completing the square is, now remember that there's a 1 here if there's not a number there. That 1 would be the A term, a -4 would be the B term, and -5 would be the C term. So if I say something about the A term, B term, or C term, then you know which number I'm speaking of. The first thing about completing the square is it's a little bit different than other things where, you know how we're always setting it equal to 0 before we factor and solve and stuff like that? Well, in completing the square, you always set it equal to the constant, which is your C term. So set equal to constant. And so what that means is we actually need to move this -5 to the other side, and that's going to change the equation a little bit. So it's going to be x squared minus 4x equals +5, right? Because to move it, I have to add 5 on both sides, and that's how I'm getting the +5 on that side. So that's one thing, is it's not set equal to 0. And so that's a little strange right there. Then what we do here is we add something to both sides. So let me show you how I'm going to set this up. I'm going to do x squared minus 4x plus some number equals 5 plus some number. Now, I could keep an equation balanced by adding both sides by the same thing, and that's what we're going to do. But what are we going to add to both sides? We're going to add to both sides a very specific term, a term that comes from your b term divided by 2 and squared. And that's really the key to this whole thing, is this step of adding b divided by 2 squared to both sides. And so what is our b term here? Our b term is -4. So what is -4 divided by 2 squared? Well, it would divide by 2 is -2, and -2 squared is 4. So you take your b term, you divide it by 2, and you square it. Now, because you're squaring it, it's always going to end up being positive. So even though this is a -4, it doesn't really matter. If it were +4, we'd end up with the same thing. Divide by 2, then square. And so that's what we add to both sides, is the number you get from doing b divided by 2 squared. And so why do we do that? Well, what we have now on the left is a factorable trinomial. And what would it factor to? It's a very basic trinomial. The factors would be x minus 2 and x minus 2. And that would be equal to, I can add 5 plus 4 on the right and be 9. But notice that it factors to x minus 2, x minus 2. It's not a coincidence that the factors are the same. And so I could actually write this as one factor of x minus 2 squared, right? Because that's what squared means, times itself. So instead of x minus 2 times x minus 2, I write it as x minus 2 squared. And that's the whole concept of completing the square, is we created a square binomial here, and it's set equal to 9. And in some levels of mathematics, that's as far as you want to go with this process. We're pretty much done with the completing the square. We're going to continue to solve for x, but this is the step that we completed the square. We're done with that part. And there's various things that you'll learn in pre-calculus where you'll go from here to move on. What we do at this stage from Algebra 2 is we solve for x, and the way we do that is we get rid of this squared now by doing the square root of both sides. And when I do the square root of the left side, I get x minus 2. Now when I do the square root of the right side, I get plus or minus 3. And the reason is because square rooting a square term is how I'm getting a plus or minus here. Because negative 3 squared is also positive 9. And that might be a little confusing to some people because we've said earlier in the year that the square root of 9 doesn't equal negative 3. That's true, but negative 3 squared does equal positive 9. So it's a little confusing, so I get why some people may struggle with that. But for now, just always remember whenever we do the square root of both sides in this step, you have to include a plus or minus there. Now at this stage, we did the square root of 9. That was a square and it became 3. That's where these problems are going to get a little bit different because sometimes it's going to be something that is irrational. Sometimes it's going to be negative, which is going to lead to imaginary numbers and things like that. So I did square root of both sides. Now I'm going to add 2 to both sides, and that 2 goes in front of the plus or minus. So 2 plus or minus 3. Okay, so that went right in front of the plus or minus. And now because these are just numbers, I can separate this into being 2, x equals 2 plus 3, which is 5, and x equals 2 minus 3, which is negative 1. And so the plus or minus actually means it's a way of writing two numbers together, but it's two operations and you would do them separately. So we end up with 5 and negative 1. Now this was a factorable term. You could have just factored it to x minus 5 and x plus 1 equals 0 and solve to get x equals 5 and negative 1. And that's exactly what we did. So why do this whole long method? Well, because of this step right here. The problems you're going to see for the most part are not going to be rational like this. Like, let's look at another example. Solve for x by completing the square. Okay, first of all, this is my b term that has the coefficient of x to the first. This would be a, and this is c, the constant that has no variable, and this is the b. So I do want the b term, the c term over here, but not the b term. So I need to move some stuff around. First, let me set it equal to 0 just to start it like we normally do. So 3x squared plus 18x plus 21 equals 0. And so there you go. Now it's a little bit more normal. Then I'm going to move the b term, the c term, sorry, over, set it equal to the constant. So set equal to constant. And so that's going to make it 3x squared plus 18x equals negative 21. And then notice that a key difference between this problem was that a is 1. And that's actually really important for completing the square, that has to be a 1. So we can't have a number here. And so if you do, the way to get rid of it is to divide everything by that. So we're going to divide everything by 3. And that's going to make our a term 1. So we end up with x squared plus 6x equals negative 7. All right, so now I have what we did at this stage in the problem here. And I'm going to add something to both sides. The number I'm going to add to both sides comes from negative b, I'm sorry, not negative b, b divided by 2 squared. So b divided by 2 squared. And in this case, b now is 6 here, is this number. So 6 divided by 2 is 3, squared is 9. And so I add 9 to both sides. Now I have a factorable term here that would factor to x plus 3 and x plus 3. And I could clean up the right side by combining this to be 2. But I'm going to write it as x plus 3 squared equals 2. And I'm done with completing the square part now. Now I want to solve for x. And I'm going to do that by doing the square root of both sides. And the square root of something squared just kind of gives me my base in here. So I get x plus 3 equals, don't forget the plus or minus, the square root of 2. What's the square root of 2? It's irrational, so it stays rad 2. And that's where the problems are going to change. Last time it was 9, and we did the square root of 9 and made it 3. This time it's a radical that cannot be reduced. And so what that means right here, the fact that we're having a radical that can't be reduced, that means that this was not a factorable term. We can't solve this with factoring or AC factoring or anything like that because our roots are irrational. So now all I got to do is I got to get x alone, and I do that by minusing 3 to both sides, and that goes in front of the plus minus to give me a final answer, and this is how I'm going to keep the final answer, of negative 3 plus or minus rad 2. And I'm not going to split them up. I would only really split them up, like in this case, because it was just plus 3 minus 3, but because it's a radical, I'm going to keep it together, and this is how we're going to write irrational roots. And so that's the solution to completing the square. So let me run through this process one more time for you. I know I'm just past the 10-minute mark, but bear with me for just a couple more seconds. First thing is you probably want to set it equal to 0 if it's not, just to begin with, because that's kind of what we're used to. But it does have to be set equal to c. So you set it equal to your constant term. And so this plus 21 came to the other side as a negative 21. If there is a coefficient to x squared besides 1, you need to divide that out. Once you're at this stage, you're ready to start completing the square. And the way we do that is with this b divided by 2 squared concept. And so whatever your b term is, which is that, which is this, the number, the coefficient of x to the first, whatever your b term is, that divided by 2 squared. And 6 divided by 2 is 3, and 3 squared is 9. Add that to both sides. We'll create a trinomial that can be factored to 2 of the same binomials. And so we write it as one of them squared. Square root of both sides, don't forget the plus or minus, and that's where the problems are going to change from one to the other, is what happens at this stage. If this was, say, negative 4, then we'd end up with 2i. If it was rad 20, I'd reduce it to 2 rad 5, things like that. Okay, so we'll spend whole day practicing this procedure.